All right. So I think without further ado, we'll get started. Um, good afternoon. My name is Sam Gralty. I'm the events manager with the Vermont Land Trust, and welcome to Untying the Knot, community-based scientific management of knotweed in the Mad River Valley. Thanks so much for joining us. If you're not familiar with Vermont Land Trust, we're a membership organization dedicated to protecting farmland, forest land, and community lands across the state. Since 1977, we've permanently protected over 640,000 acres, which equates to roughly 11% of the state. Before we fully begin, just a few brief Zoom reminders before we get started. We are recording this, but because it's a webinar, none of the folks who are attending will be on the recording, so don't worry about that. To begin, we have the chat open so people could kind of put where they're coming from. In a minute, I'm going to shut down that chat so folks could just only chat with me, but there is a Q&A feature that we'll be utilizing. So I definitely highly encourage folks throughout to put questions into that Q&A feature. And also, as you see other questions that you're interested in, you can give those a thumbs up to upvote those questions. So we'll hopefully be able to get to all of the questions at the end, but in case we don't, we're going to prioritize the ones that seem to have the most interest. So if you see another question that you really want to make sure gets answered, give that one a thumbs up in that Q&A feature. Let's see. If you have any technical issues, feel free to send a chat directly to me, and hopefully I'll be able to take care of that. And one last thing, if you would like closed captions, we do have closed captions available at the bottom of your screen. So yeah, I think without further ado, I'm going to pass it off to VLT Forester Peter Van Loon to get us started with a little background and setting some context for our discussion.
Great. Thank you, Sam. And thank you, everyone, for coming today. I'm really excited about this presentation because it's a story of communities coming together to protect those things that they value. The Land Trust has been working on introduced invasive species education and control for almost 20 years now. And recently, we've been putting our resources into supporting groups around Vermont that are working cooperatively to help the communities and citizens help in what I like to call their invasives journey. In almost every webinar or other event that we've done regarding introduced invasive species, there are questions about knotweed. Do a webinar on buckthorn, and people ask questions about knotweed. Why is that? It's because it is everywhere, and it's recognizable, and it's difficult to even figure out where to start in controlling it, no less how to actually control it. And the nice thing about the presentation you're about to see today is that this group has been working on knotweed from a control viewpoint on larger infestations, and also is looking at areas in headwaters where it's more of an early detection, so-called species. There's smaller infestations. So whether you're dealing with an established infestation on a local river or a new patch that you've discovered somewhere on a small stream or a reed or a roadside, you'll learn a bit today about what's worked and what maybe you might want to avoid. And with that, I think I will pass it off to Kurt and the rest of the presenters to introduce themselves.
Okay, thank you, Peter. Next slide there, Sam. So we have a team of folks who have been involved in the Mad River Valley invasive species and knotweed effort. We have Walt Pullman from UVM, Hedo Coleman from the Warren Conservation Commission, Andrea Henderson from the Fayston Conservation Commission, and David Maroney, who is our GIS coordinator. And I'm Kurt Lindberg from Waitsfield. Next slide. Think about this for a couple of minutes. Right. Good old New Yorker. Next slide, please. All right. Wanted to just give a little history on how this effort got going. And it goes back probably 7 years or so. And there's kind of a two-step early work on this. Hedo Coleman from Warren, I think, was traveling both the Roxbury Gap Road and Lincoln Gap Road and started to notice knotweed growing in both locations. He got pissed and he started ripping out knotweed in both locations and kind of keeping track of what he was doing. I think he even got more angry when the Forest Service had Lincoln Gap Road resurfaced, and gravel that was brought in for that job seeded many new knotweed infestations. At about the same time in Waitsfield, the Conservation Commission began a floodplain forest restoration effort along the Mad River. And this property was infested by many invasives, including knotweed. Ito and I began comparing notes and kind of noticed that we were kind of making progress. So that began the collaboration between the two towns. And then when we learned that E.O. Wilson claimed that invasive species were the second leading cause of biodiversity loss, that really energized us even further. So next slide, please. Okay, well, hand off to Hito here.
Thanks, Kurt, for the introduction. When we started, we really didn't know very much, but we did sort of start getting an understanding of the plant and what it could do or not do. And these guiding strategies, I would say, emerged over the first 5 years of our work that continue to guide us today. And we do a lot of lessons learned at the end of a season, as you can might imagine. I'm going to talk about the first two of these. The focus on watershed became really obvious to us as many people know, knotweed goes up the hill in a gravel truck and it comes down in the water, streams and rivers and alongside the roads. And it isn't going to travel any other way. We are lucky in that the knotweed that is here in the Northeast is a all-female varietal. It produces flowers and nectar for the bees, but it doesn't produce a viable seed. So its only way this thing, knotweed, can spread is really by the movement of the roots, the rhizomes, the nodules that will reemerge. And they are tenacious, and you have to respect them. But that's really where we started. Maybe we should go to the next slide. You know, when we started this, the knotweed infestations lower along the Mad River Valley were daunting. I mean, just huge swaths of knotweed. And we said, well, if it does come down the rivers, let's start at the top and work down. So we really did start at the very top of our waters in the town of Warren, which happens to be the headwaters of the Mad River. And we've been working from the top of the tributaries down, making sure that the knotweed, and this is small infestations that literally were started typically along roads by gravel trucks. It all could be the telephone company putting in a new pole, or anywhere where gravel's been moved, it's contaminated, and we can get after it. And these are, like I say, very usually smaller sites that we're lucky enough to get early. Getting to the sites early is very important, because it has less time to establish itself and to start storing energy in the underground part of the plant. Where we are today, after 7 years or so, is above the town of Warren on the 4 or 5 major tributaries. We no longer have knotweed infestations that are not either eradicated or managed, which means we no longer have propagules coming into the Mad River from the upper part of that watershed. And that's a big statement, because that means we will not continue to feed propagules downstream, so that as we work downstream now, we know we have a chance of keeping our work can sustain itself. Let's maybe go to the next slide now, just to sort of take up a little bit of what we mean. So we've been lucky enough over the years, and quite frankly, very lucky recently, that with the help of UVM and Dave Maroney, to actually find a GIS mapping program that will actually do the job for us, because we need to keep track of all these sites. And this is just an example of the number of sites that we have that are actively being managed. There's another map that includes ones that are known but not managed, and then there's a variety of other things we do to increase our scientific information related to knowing what we're doing and keeping track of all that. So maybe we go to the next slide here. I don't want to race. I'm typically a racer in these things, but I just wanted to highlight how there's a lot to cover here. And in this particular time, we have a very full agenda. So I'm going to go faster than I would normally, that some of this may need, but you can always come back to us with questions. So in our management methods, these are all organic methods. We're not using any pesticides. That is an active way of controlling it. We decided early on we were going to stay within a biologically organic, ecological thing that we understood and appreciated, and we haven't been using chemicals in the rest of our lives, so why start doing it now? All these management methods listed here are very similar in the sense that we are attacking the root structure. There is, substantially more biomass underground than there is above ground with knotweed. And when we ripping, pulling, digging, cutting, mowing, and grazing, those methods all are an attempt to starve the root structure. And the way you do that is you let it grow and let it get up to, say, 2-3 feet in height, and then you get rid of it. But whether you mow it or you put animals on it or you rip it up, you basically remove it. And that energy that it took to grow that was not going to be replenished. That the stuff we remove is no longer putting energy back into the roots. And knotweed will try again. It'll send up a new shoot. After time, it runs out of energy. And we're lucky that we're tackling sites that mostly are under 10 years, definitely under 25 years. So we don't have a long standing problem like Southern England, where it's been 200 years. They have a much different problem, and probably our methods would not work there. But we have a chance of wiping it out because it hasn't been here that long. Of those methods, ripping, pulling, digging, basically just get it out, and once you get it out of the ground, and this includes roots and rhizomes, it dries out and it dies relatively quickly and becomes inert. Cutting and mowing in the same way just eliminates the vegetal part, above ground part, and no energy is put back, but you haven't really dug down and gathered any of the energy. So the ripping, pulling, digging process, which is now our favored method, is time intensive, but it does a really good job of eliminating the knotweed there. I can say that if we were to attack a site with these methods, if we spent 5 hours the first year, we'd only spend 2.5 hours the second year, and it goes down by halves. So after we're at it a couple years, and you do have to be committed to coming back, because you haven't won in the first year for sure. We basically try to attack it every 3 to 4 weeks from late May to October. And the effort that it takes after a couple years is surprisingly small. And this is where the mapping is important so that we can have people do that. Of those methods that I've listed here, the smothering is the only one that isn't attempting to kill the knotweed by attacking it and starving it out. It's basically covering it so it goes into a dormant phase and eventually dies out. And we're having very good luck with smothering. It does take about 5 years, and there's some literature that supports that 5-year period. We have a number of sites we're testing, so. I think that's the end of my part of this. And but like I say, you can always get back to us if you want to know more about any of these methods. Next slide. There we go. Oh, this is one of our interns basically ripping it out, and we use a drying pile. We just pile it up so that the roots, you can see the roots and the rhizomes coming off the end of these stalks. They just sit out in the air and they dry up, and typically it takes weeks. Depends a little bit on the atmosphere. Let's go to the next slide. That's after the pile has sat around for a while. It dries out quickly, becomes pretty inert. We then spread that back on the ground after it's completely composted. All right, go ahead. We did establish a knotweed dump. Early on, we didn't know what to do with the stuff, so we actually found a place in town that was contaminated, and we proceeded to haul material there. The new method where we pull and dry on site has saved us an enormous amount of energy and labor, so we no longer are hauling it away. We do provide a dump for anybody else who wants to haul it away. If they've got it on their property and they don't really understand it or don't trust their methods, they can come bring it to our dump. Let's keep going here. This is a smothering site. Our smothering techniques have changed over time. We use cardboard, which actually was an idea that came from Mary Waltz up in Hyde Park, to protect the tarps that we were using to cover the sites. I've now used vinyl billboards as a much better product. It can handle being put down straight on the knotweed, and the knotweed doesn't puncture through, and it saves using the cardboard stage. But any way you can get it covered up and keep your tarp in good condition, because the knotweed will be looking for a way out, and it'll go 10, 15 feet looking for a place to get out and get some sun, and that then stops your smothering function. Go ahead. Next slide. Mowing is successful. It's been used a lot in a lot of places. Just keep mowing it. It'll die eventually. It does tend to get into a slightly different state where it grows low to the ground, but it works. And the next slide is grazing. We last year had both sheep and goats grazing knotweed, the same functionality as mowing effectively. The goats were much better than the sheep. More than half the goats' diet when they had a choice was knotweed. So they really loved it, and they keep eating it all summer. This year we'll be getting some goats back again to continue that work. All right, next slide. All right, I'm turning it over to Andrea, I think, at this point.
Yeah, thanks very much, Hito, and Kurt and everyone. So, as the title or part of the title of this webinar includes the word community, and that is a really large part of what we're doing here. We're engaging the community, and in engaging the community, we're developing, I don't want to say enthusiasts of knotweed, but enthusiastic in the management of knotweed, myself included. And I was working just, as a volunteer with Kurt in Waitsfield. And it's been a growing opportunity learning about the plant and now being able to share more of that knowledge with the community and you all today on this webcast. Next slide, please. So here we have some pictures of volunteers as well as interns, other commission members. You can see in the picture on the right, we have volunteers from under 10 to over 70 and everything in between. It can seem like a daunting task working with this knotweed, but really every age can get involved and it's further building community and collaboration in trying to manage these or this particular invasive species. Next slide. You'll see here some commission members. Kurt and another commission member, Bob Cook from Waitsfield, and then on the right, a site in Fayston with some of our interns and community volunteers very enthusiastically managing the knotweed. And one of the session here on the right is one of our throughout the Valley towns weekly community knotweed sessions where our volunteers are working alongside the interns and ourselves. And it's a wonderful opportunity to collaborate again on this particular management effort and to get to know other members of the community, students at UVM, and Conservation Commission members. Next slide, please. So this Mad River Valley, Green Valley initiative, this got started around another project, Green Up Day, but we utilized this as an opportunity for community education about knotweed and invasive species, as well as volunteer recruitment. And we were quite successful at getting quite a number of new members of the community involved in the knotweed management efforts. This will be our third year, confirmed for Green Up Day and the Green Valley Rally, first Saturday in May. Here on the right, we've got one of the many Mad River Knotweed Instagram posts. You'll see these wonderful pink shirts. Again, another symbol of community that the interns designed maybe 2 years ago now. A number of the interns in this photo, as well as conservation members and volunteers. So, great community and getting the word out as well via social media. Next slide. So in addition to social media, we also, both commission members as well as our interns submit updates to our local paper, the Valley Reporter, which is a wonderful partner at getting the word out and educating the public, as well as UVM taking some reflections from one of our interns of 2 years ago and sharing that both in the paper with an article that he'd submitted, as well as on the UVM website. Next slide. This was started by the conservation commissions and it continues to evolve over time. So informational signage regarding the Japanese knotweed itself, what it is, what it's doing, why is it a problem, what can we do about it? You'll see on the slide on the right, which is posted. I think that might have been posted up in Warren. We've got a slide or a sign here on the left with respect to the smothering sites, and have created together with the UVM interns and iterated over time with respect to the different methods that we're employing, and having these signs at various locations around the valley where the public can take a look and see what we're doing. We also take these signs along with us when we are, next slide, at community education events. This is a community education tri-town program that we did a few years ago at LaRue. It was recorded, included on the MRV TV website, and is still actually available there. You can find it on the archives, where we had Hans Estrin, I think. No, Brian Colleran was leading this for us and sharing information about his experience with knotweed management techniques. Here we're digging up and we're seeing propagules that have been floated down the stream in various floods. And we, quite a number of community members joining us and learning and engaging. So just spreading the knowledge and what can be done about the knotweed and managing it. Next slide. All right, back to the goats that Hito was mentioning. We had a great community engagement with the goats. Here they are shown munching along. You'll see the knotweed at the right, where they've already pretty much decimated it. We had an event like a meet and greet with the goats, and a lot of enthusiasm around them and the work that they're doing in helping us manage knotweed in the Mad River Valley. Next slide. So one of the things that we have been doing at least 3-4 times throughout the summer is tabling at the Waitsfield Farmers Market, which has been really an excellent opportunity to educate the public. You'll see we bring along a couple of stalks of knotweed to show people who might not know exactly what it is and what to look for, the live plant itself, as well as a lot of our signage. I'm there often with the interns, talking to the public, posting about what we are doing, providing updates, and just really, engaging with the public. We did also have the goats there to talk about the work that they were doing at one of the farmers markets this year. And this last slide, I think, in the community engagement is a group of Harwood middle school students that came out to help us this year. They come throughout the valley to help on various projects. And this year they were working with us to plant willow skeins in the LaRue Tardy property here. And this is our thank you letter to the Valley Reporter with respect to the great work that they did. Very engaged, including their 2 teachers along with them. I don't know, maybe we had half a dozen or so of these middle schoolers working, quite hard. And I've heard a lot of feedback as well from parents of them, how impactful this opportunity was to get involved with the knotweed management. Next slide. And I will turn it over to Walt Pullman. Thank you.
Thanks, Andrea and Kurt and Hito, and good afternoon, everybody. Walter Pullman from the University of Vermont. And I want to share with you just a little context about how UVM has gotten engaged with all this great local energy. And you probably realize that hearing from Kurt and Hito and Andrea, they're from conservation commissions in 3 adjacent towns in the watershed. And this was really inspiring to us to see this watershed scale collaboration. And I want to share with you about the Ecological Planning Laboratory. It's a new community outreach effort at UVM to support the work of communities, really at the watershed scale. How do we leverage what we have available? And I'll go through some slides here. Sam, you can go to the next slide. And I'll just basically say, what is this thing? It's a partnership of a program I direct, the Field Naturalist Graduate Program at UVM, which is really a training in conservation science, integrated field science and communications, together, and really importantly, with UVM Extension, which, as you know, is the land grant function reaching out to communities to support often work in agriculture and forestry, but increasingly at the watershed scale. And we look at it as sort of an ecological extension service where we can provide assistance, help to communities to help them really develop resilience in the face of climate change. A lot of this is very climate change related. And as you're well aware, if you're from Vermont or even beyond, that we've had just intense flooding related to climate change in all seasons, and resilience is what we're trying to cultivate, and we want to be part of that. I want to emphasize this watershed scale planning. Although it's focused on knotweed, it's really a gateway into the watershed. Floodplains are critical aspects for everything from food production to biodiversity to water quality, flood resilience. So this is a chance to really get in and be focusing with communities on watershed health. So that's what the Ecological Planning Laboratory, just in its pilot phase, is all about. Next slide. Just to get a sense, it's sort of an emergent quality. You know, we came up with this idea of bringing the FN program together with extension and a whole range of resources, and really ask the question, how can the EPL connect and mobilize the resources of the university to empower Vermont communities to develop resilience in the face of climate change and other destabilizing forces? We didn't know the answer, but we know we have a lot of resources, and we can bring them together with just the incredible energy and expertise that exists within communities, that type of synergy might result in things that move the dial on enhancing resilience and addressing big issues like biodiversity protection. So that's our mission question that's guiding us. Next slide. Here's just a little kind of diagram or a little puzzle sort of showing we wanted to bring the pieces together. The Field Naturalist Program, we have 40 years of doing community outreach in Vermont and beyond on conservation science issues, together with summer interns, and this is really key. You saw many pictures of summer interns involved, and UVM really prides itself on getting its students out into communities. Students absolutely love this. I teach a big course with 300 undergraduates from the Rubenstein School, and they're almost all of them are really keen to be working in communities doing this type of conservation work. So we want to leverage that, the graduate students in the FN program, but really importantly, the research faculty, research into invasion ecology, and bringing some of our excellent researchers from plant biology and the Rubenstein together with communities. And then, of course, there's a spatial analysis lab, which is really kind of state-of-the-art remote sensing, drone coverage to really look at what's happening in these floodplains and in these river corridors. And here's the key, together with extension, this whole idea of doing community outreach and working on the technical aspects in a long-term way. Extension provides this. Next slide, you'll see we wanted to pull this all together into the Ecological Planning Laboratory, connect the dots, bring our resources to bear, and then, next slide, partner with communities. And you can already see that the communities are linking together at the watershed scale, whether it's middle schoolers, community volunteers, businesses, the farmers markets, you name it, it comes together. And when these come together, this is really the vision. If we can bring these together, we can tackle big picture issues such as invasive species in the floodplain, cultivating flood resilience, and enhancing local food production, and really tackling this biodiversity question at the watershed scale. That's what this Ecological Planning Laboratory is all about. Next slide. Here's just some photos. You've seen a number of photos. I'll just, you're going to hear from Dave next on the left side, a field naturalist that I've worked with the last couple of years doing great community-based work. There's a guy from the Spatial Analysis Lab programming the drone to get real-time footage of what's happening in the floodplains, together with UVM interns and ecologists, scientists from UVM on the right side working with Kurt there to really set up long-term studies to really test what works and how to make it happen more successfully as we move ahead. Key integration. Next slide. So this is a little bit of, just numbers from 2024 in the Mad River Valley. Interns working many, many hours together with volunteers. And that's a key thing, integrating the work of UVM students together with the community members is just an amazing synergy. You can get a lot done. A lot of mapping, a lot of tree planting. We actually really tried hard to capture these stories, and we work with Bright Blue Eco Media to do a lot of capturing videography and telling the story of what's going on as a way of sharing it. And you can find this on YouTube now if you want to see a 6-minute version of this that's been captured. So that's a big part. Storytelling of successes is key. Next slide. And looking forward to 2025, we're already planning right now. We want to return to Mad River Valley, have UVM with interns, with scientists, with Spatial Analysis Lab, with the graduate students all working together with the community. We're really looking forward to expanding this into southern Vermont and northern Vermont to do really more emphasis on watershed scale restoration. Last slide I'll show is just a big picture of how this fits into state policy. As people are probably familiar with, if you're on the call from Vermont, Vermont's Act 59 is really this idea of cultivating community resilience and biodiversity protection throughout the state. can we conserve 30% of the land by 2030 to protect biodiversity and cultivate community resilience? So this brings together UVM together with policy, together with local communities to promote watershed scale health. I'll stop there and pass it on, I believe, to Dave Maroney. Next slide.
Hi, folks. My name's Dave Maroney. I'm the GIS coordinator for this project, and it's great to see a lot of familiar faces in the audience. I know many of you from my work with the Community Wildlife Program at Fish and Wildlife, but I'm involved in this project independently as through the Ecological Planning Laboratory with Walt. And in that context, my role here is to really bring GIS tools to this project in terms of mapping data and learning lessons from that map data. Now, Walt mentioned that the EPL's project is really to think about how it can leverage the resources of University of Vermont to help communities. And when the EPL got involved in this project, one of the most obvious ways that it could do that is by providing access to ArcGIS Online tools and professional level GIS tools to help keep track of data and learn lessons from that data. So I'm just going to take a couple minutes here to talk to you a little bit about what went into that in terms of this project and how the project has evolved and grown as a result of that collaboration. Next slide. Okay, so you saw this image earlier, and when it comes to sustaining a project over the long term, a number of things need to happen. And one of those is that you have the data that you need to effectively keep track of a project, especially when it comes to managing knotweed and managing invasive species in general, is that it's never a one and done situation. And I saw somebody ask earlier, how do you make sure that you get every little propagule of knotweed? Because it's going to come back even if you just miss a tiny one. And the answer is you can't, right? The only way to engage with and manage a species as tenacious as Rhaenutria japonica is to make sure that you are coming back over and over again, so that those small propagules that you miss, those root structures that are left intact, can continue to be managed no matter what your methodology is. And so keeping track of sites is one kind of data that needed to be tracked effectively in this project. In Fayston and Waitsfield and Warren, they all started doing that independently in a very grassroots manner. And so one of the tasks was to figure out what kinds of data were being tracked and how we could pull those together into a single unified, consistent data set for the 3 towns involved in this project. So knotweed management sites, just one kind of data. And the second sort of question is, who's taking this data, who's participating and creating this data? And this data set right here is something that is created by the interns who are trained in how to manage these sites. It's created by the leadership team involved in the conservation commissions and contributed to by different members of the community. Next slide. But there's lots of data involved in this project, and especially as the project has grown and branched out, and scientists have gotten involved from the University of Vermont, there's other kinds of data sets that we're tracking at the same time that are collected by different people, require different standards. So this is one example of that, which is a location of different monitoring points throughout the valley of where Conservation Commission members established long-term plots that would be sampled periodically so that we can learn about what is changing and how methods are effective in various ways. And a whole bunch of new plots have also been added to this. Next slide. One more example of just the different kinds of data that are involved in this project is that as the project has grown, it's become important to not only understand how knotweed management is going, but the impact of knotweed management on other invasive species that cohabitate these ecosystems. And so this fall, a process was undertaken to sample different sites throughout the valley for terrestrial invasive plant species beyond knotweed, so that we can see, okay, a lot of effort has gone to controlling knotweed, but down by the rivers in certain parcels, that has made room for goutweed and secondary invasions. of different species. So we may have to adapt strategies to make sure that different ecosystems are managed holistically based on what's going on. So that work was tracked separately. Next slide. So this is just a quick image of that tracking work that happened in terms of surveying and sampling these different invasive species at these locations. I'll skip over that just to be brief. Next slide. Okay, so all these different kinds of data are being tracked in this project. And so to facilitate that, as I mentioned before, we turn to tools of ArcGIS ecosystem, this Esri ecosystem. And we used ArcGIS field maps and ArcGIS Survey 123 to create different sets of maps and forms so that all the different players and participants in this ecosystem of data are able to enter the information and participate in collecting these data sets over time. So we have a form for management, a form for scouting new instances of knotweed infestations, a form for those terrestrial plant surveys. And this allowed flexibility to collect these data and put them into a single system. All right, to close out here, just brief tour of the sort of GIS technology portion. I'm going to give you a very quick screen share tour of the system that I created to track all of this data and allow others to see it and interact with it. So what we created was a data map or data explorer that shows all of these different kinds of data together in one place. It's an interactive, this is an ArcGIS online web app. And all of these different data sets, including ones that I didn't have time to talk about today, are tracked in the same location and can be interacted with by different members of the team and the public so that everyone can see what kinds of data are being collected. They can look at the results of surveys for invasive species. We can collect and view, for example, before and after photos for when management is occurring. So this is some data that was input into the system from interns this summer, showing the before and after from a single knotweed management. And all of that data is then coordinated under a dashboard app that the leadership team and the scientific research team involved in this project can take a look at, not just the map of where interesting things are happening, where the different data is being collected, but can also interact with that data in a tabular format and start to do the statistics and the analysis that allows folks to learn lessons about what needs to change over time and how this project can evolve. So I'm going to stop there. That's sort of a quick tour of the GIS and sort of technology side of this that's been evolving with the project. And I'll turn it over to the next presenter.
Okay, next slide, please. Sam. Keep going. Very quickly, early detection, rapid response. I think you folks all know about. Here's a champion 12-foot knotweed rhizome found after a December 2023 flood. Next slide. In our system, we've mapped the locations of all propagals that were spread by that flood to help us know where to go in future floods. Next slide, please. So we cleaned up about 1,000 propagals after that flood in those different mapping locations. So if flooding happens again, we know where to go back to. Next slide. Emergent design is a process that we've used to help increase the sophistication of our effort and to engage communities. Next slide. You've all seen these beautiful images of birds flocking or murmuring. What does that have to do with emergent design? Turns out that these birds create these gorgeous patterns and adapt by interacting with one another, and the interactions form these patterns. Turns out the same things happen in human systems. If we want to be creative and adaptive, we need to be talking with one another, involving diverse voices, and listening carefully. It's from those conversations and interactions and relationships that develop that allowed, I think, our program in the Valley to grow and develop and become more comprehensive and more science-based. Next slide, please. Okay, we're going to talk very quickly about results and then wrap up in a couple minutes. So, Hito.
The biggest message I can send out to people is if you're gonna get after it, make sure you're committed to the long term. If you can't keep doing the work, your energy is wasted. So if in our case we limited the number of sites we would attempt to tackle simply because we had a limited amount of manpower, and that served us well because we were very effective on the sites we stayed after, and we slowly grew as we spent the time. We slowly grew, not only learning how to do the work better, but also understanding how to have a bigger and bigger impact each time we did go there.
Right.
That
okay, some early results. You saw that we collect data on measurement plots throughout the Valley, and from 2023 to 2024, the number of stems in those sites reduced by 47%. The stem diameters were reduced by 50%, and the coverage of the plots by the knotweed dropped by 25%. And as Hito mentioned, the time required to manage sites dropped by 50%. So we've become more and more efficient. So Andrea, to you.
Sure. Thanks. If we can go to the next slide. Although the ones that we were just looking at, right, was a before and after of the exact same spot after a couple hours of UVM intern management. Again, a site that we've gone to over and over again. And as Hito and Kurt have both shared, the amount of time it takes to manage that site continues to drop significantly. So we do hope at one point that we will not have knotweed there. This is a map of the additional invasive species sampling that Kurt and Dave talked about. So this was accomplished this past fall, and we have, a very thorough and well done report on the other invasive species that we have at these various locations. Next slide, please. So what's the point of getting rid of all the knotweed? We want to restore these riparian buffers. The knotweed really doesn't do anything to help us in terms of flooding and so forth. So restoring these riparian buffers is the next step. And that is underway in all three towns. And again, community involvement. So you'll see here a post from Friends of the Mad River, some pictures of individuals from Friends, as well as conservation members and community members working together to plant these native species throughout the floodplains, and even, a bit above, alongside streams, also, in Fayston, where, we're not in the Mad River Valley or the Mad River floodplain itself, but we have, banks that certainly can benefit from native species as we remove the knotweed. Next slide, please. The number of plantings is significant. By next November, we'll have planted over 2,200 native trees and shrubs at 6 different riparian sites. And this site here on the right is a steep bank, is that same steep bank that you saw the before and after. So we also protect these saplings with these tubes here and mark them so that we're sure not to accidentally cut them as the knotweed might be coming up around them. And also you'll see some of the recent signage from last year talking about what we're doing, what the plant is, and how we're managing it. Next slide, please. Again, more pictures of the community. Again, Conservation Commission members, children of Conservation Commission members, partners of Conservation Commission members, and young families, getting people involved and getting them involved at a young age. So they're caring about our environment, caring about this effort, and they may become the next leaders of this initiative. And then making sure that that we're able to get the word out. So utilizing social media, not just ourselves, but with partners like Friends of the Mad River. That wraps.
Okay, Sam, that concludes our remarks.
Great. Well, thank you, everybody, and especially thank you, folks, for submitting questions. We will definitely get to as many as we can. I'll do my best to collect some as well. We may go a little bit with some of the panel beyond one. So if you can stay with us for that, that would be great. But again, we are recording this and everybody who's registered will get emailed the link once it's been processed and up on our YouTube page. So before we go too much further, I will say that a lot of the questions were about sort of best practices. So could anybody on the panel speak to any resources around the actual physical management and removal that you all have utilized that you would suggest could maybe answer a lot of these questions around best practices around actual management?
Ido, you want to take that one?
I'm sorry, I was muted. Probably the best thing we could do is we have our own internal little worksheet that we developed as a way of communicating to all our volunteers. And maybe to a certain extent, that would be a great thing to make available. We certainly would be happy to share that. I think a lot of people's questions, I'm going to tell a little story. We're going back when we started. The prevalent feeling in the valley anyway was that you couldn't kill it, and so we spent a lot of time trying to figure out what the plant was like, and in that process, we took hundreds of plant parts, shoots, rhizomes, roots, and dried them for various amounts of time, and then replanted them in in like gardener's cups and places. And from that experience over 3 years of doing that, we learned that the vegetative part above the ground dries and becomes inert in under a week, some of it in 2 or 3 days, depending on your drying conditions. And all of a sudden you start thinking, oh yeah, this stuff does die. It isn't like a miracle. And yes, small propagules can restart, but if it's a dry section, they're very unlikely. Anyway, that gave us a lot of confidence to just go after it. And as I think David said, if you're going to come back to a site, as you should, every 3 or 4 weeks, if you didn't get it all or you drop something, it's going to be some small little tiny shoot you're going to see and you pick it up then. It's going to tell you it's there. So it's a little easier. It isn't so heartachy, heartbreaking, worrisome that there's going to be a piece around that you're going to miss and it's going to create a whole new infestation. It takes a while to grow, and if you go back, you'll get it. I did see one comment related to, mowing and or using a weed whacker or something, and we don't recommend you do that right next to the rivers because you have a chance to throw it into the watershed. But we've been pretty successful, surprisingly successful at using that technique to move quickly through a stand and knock it down, and then just come back and the new shoots will come up, and you do it again, and pretty soon you had tremendous success with that. We quit being so afraid of the plant, and we're pretty openly, maybe a little chaotic. Even you just go at it, and you make impact.
Can you talk, earlier you had mentioned about the knotweed being female and not having fertile seeds. Could you talk a little bit more about that?
Well, that's as open as I can. There are three kinds of knotweed. The kind of knotweed we have in northern Vermont is all female clones, and there's another kind of knotweed, big leaf knotweed, and then there's where the two got together. It's called Bohemian knotweed. That is much more difficult. It does produce a viable seed, and we're lucky we don't have it here, and we're on the lookout for it all the time. But because the plant is literally a clone and they're all female, it gives us a chance at really attacking it differently than almost any other invasives you ever heard of, because they're all prevalent. You're always worried about seeds and the spread of the seed. And we're lucky that with knotweed, we don't have that as the basis of the plant's existence.
Gotcha.
I mean, I keep saying knotweed got here because we put it here, and we have the power to not put it here. And so we really have to get after it and understand that.
Actually, that's a perfect transition to the next question I was going to ask, which is about preventing source populations from gravel distribution. Have you had any luck in terms of finding ways to get treated gravel or things like that?
So the first thing you look at when you know the Vermont story, the Warren story, is after Tropical Storm Irene, the little bit of knotweed that was in the valley got deposited in gravel. The gravel was extracted from the rivers to save the roads, and that's when it all spread. That one was the major infestation point, because two things happened. One, the gravel hauled it upstream, but Irene spread it all over downstream. So that was when it really broke out. It was here, but people weren't paying much attention to it. That's when it really broke out and is going to continue to spread. We in the town of Warren, the best thing we did was convince the town road folks that they should quit spreading contaminated gravel. And to a large extent, they've gone to using Staymat, which is a manufactured product from ground up gravel, if you will, but it's ground up rock. That is a very excellent road quality material that is not contaminated. We've also tried to get people to be aware of ordering knotweed-free gravel, which is very hard to get, but it can be acquired, and because most of the gravel pits understand where it is and where it isn't within their pit.
And Sam, we also encourage people who have had fill brought into their property to look to see if any knotweed's starting to come up, and then use the early detection and rapid response. Get after it when it's young, and you can get rid of it soon.
Great. I'm honestly not totally sure what this is referencing, but I'm curious, and other people seem to be as well. Oh, I just lost the. Does mowing and smothering have any effect on knotweed's allelopathic tendencies?
The allopathic tendencies of the plant is its ability to suppress other plants through the introduction of chemicals into the ground. And that characteristics has been noted in the literature. We find that the new plantings that we see, or the young infestations, the quality of the allopathic chemicals are not consistent. They're gone within months. We see rapid return of native species literally within weeks and months of pulling it up. I can't speak to long established locations. Ones that have been there for 20, 30 years, they certainly would have more of the allopathic chemicals in them, but we have not seen that and we have not concerned ourselves with that as anything to deal with.
And Sam, we've been pretty aggressive planting native trees and shrubs in locations where we've been managing the knotweed. Some literature says, wait 3 or 4 years before you do that. And we decided to, get a little experiment going by doing it sooner and then tracking the results. But certainly with the 2 invasive species ecologists from UVM that we're working with now, I think we're going to get much more sophisticated about restoration, the types of species to use, when to plant them, use more herbaceous material in addition to kind of woody stems. So we expect that our restoration efforts will change as we learn and bring in more scientific guidance.
There was a question actually that I saw about disrupting soils and any worries about erosion between knotweed removal and plantings. Have you had any thoughts about that or seen any evidence of one way or the other on that?
Well, what we do where the soil is disrupted, where we've dug, especially along waterways, we throw down a conservation mix, and sometimes some straw to get things growing kind of quickly.
One question too, you touched on it a little bit during the presentation, but what are some options or best practices for what to do with material, knotweed material, once it's been removed? I saw the stacking and drying. What are some other options that people could consider for what to do with it once it's been removed from an area?
Well, we established the dump to give people a place to put it. And people across the valley do utilize the dump as a way of going. And literally, it does the same thing, except we don't actively try to manage it. If you have stems or above ground material, any way you can get it to dry out, it'll die. And we're talking a week or 2 in good drying weather. The roots and the rhizomes are much harder to dry just because of their structure and they take longer, but you definitely shouldn't put it in your compost, and you definitely don't want to leave it laying around. If you leave it just laying around in a moist area or in a pile, it will sprout. And even in some of our drying stacks, they'll sprout on the edges a little bit, and we'll go back and just pick through it and solve the problem. So it's a tenacious plant, and you have to respect its ability to restart.
One question.
One addition to that. We've worked hard over the years to become more and more efficient, so we can kind of tackle more territory. And one of the tools that wasn't shown in the tool slide is a weed whacker with a blade on it. We use that now to manage some of the more heavy infestations. So it cuts very well. And then in a lot of locations, if it's not right along the river, we just let those stalks dry on site. We don't stack them, just let them dry. And as Ito mentioned, because we're going back there so regularly, we'll notice if we have a problem. So electric weed whackers are a great new tool.
That's great. One question, sort of bringing it back to the bigger picture. If obviously you all have done a lot of work behind the scenes and building up coalitions and community, but if people wanted to try to start doing some replication or doing a similar thing in their area, what would you recommend in terms of first steps? I saw one question about funding. So funding or otherwise, what are your recommendations for how people could take a similar approach in their area?
Yeah. Andrea, you want to take a shot at that? You're on mute, Andrea.
I was trying to click on my picture to unmute myself. That's not effective. FYI. I'm thinking back to how I found out about all of this. It was a front porch forum post, and I think I answered one of the Q&A questions posed on that. And a brief article in the paper, front porch forum posts, those seemed to be quite effective early on, talking it up amongst friends. Not every community is going to start, a rally like we started, but farmers markets, tabling there, all of these get the word out. And it can just start small. It doesn't need to start with 50 volunteers. It can start with a handful of volunteers. There are other organizations, not in Hyde Park. Mary has, they're working to combat it there as well. So just start small, and it can grow from there, and the enthusiasm grows as well.
One of the early steps we took, we used iNaturalist to map as much of the knotweed as we could find in the valley, and having a picture of that proved very helpful in telling the story about the problem and engaging the community. And it also led to the strategy that Hito described of, where to prioritize early efforts, so the headwaters, upper elevation locations throughout the valley. So I think the mapping was an important early step for us.
I guess, are there any questions that any of you on the panel saw that you want to get to, or anything that we haven't covered that you want to make sure we get in before we wrap up? All right. Well, like I said, go ahead.
Yeah, I'd encourage anyone who's interested in this issue to see if they can't get something started locally. There are many in Vermont who understand that invasive species are the leading threat to healthy ecosystems in our state. So we all have to do more. And my hunch is if you can get going locally and form some partnerships, you'll find it very gratifying work that has an impact.
Yeah, and we will definitely follow up with resources. We'll also look through the questions, and if there's anything we can share resources for, we'll definitely do that. We can certainly share the handout that Hito was talking about as well. So be on the lookout for follow-up email about that. Again, like I said, this is has been recorded. So once it's processed, we'll share a link to that as well. So I think that's about does it for us today. Thanks so much for joining us. We've got some upcoming other VLT events. We've got a ski party in Stowe. We have a couple other webinars coming up. We have one on March 14th about ash and emerald ash borer. We also have one about spring wildflowers on the 18th. I encourage folks to follow us on social media, as well as follow Mad River Knotweed on social media too. And yeah, if you are able to, please consider supporting our work. We couldn't protect the home we share without support from folks like you. So if you could do that, go to vlt.org/donate. And yeah, thank you all so much for coming, and have a great day.